Okay, today I'm going to be looking at coordinate geometry and everything that you need to know about coordinate geometry for Pure Math 1 from the Cambridge system. So here's a little summary of what I have. I'm just going to talk through each of these points. And this is really, if you know your theory, you should be able to tackle any question with this theory. So first of all, you need to know these formulas here in pink. We've got the gradient formula. So if you're given 2 points, point A and a point B, can you find the gradient between these 2 points? And that is simply our y is our change, sorry, our gradient is our change in y over our change in x. It's very important just to make sure that your y is at the top and your x is at the bottom. It's very easy to write them the wrong way around. Okay? So that's how we find gradients, and then I've just pointed out two special gradients. So if anything is parallel, it means that the gradients are the same. And then if you have perpendicular gradients, it means that your one gradient times the other one should be equal to -1. There you're going to have so parallel gradients are the same, and then m1 times m2 is equal to -1. That means they are perpendicular. Okay. Then the next thing that you need to know is how to find the midpoint between 2 points. So if you're given the coordinate of A and B, then you can find the midpoint basically by finding the average of the points. So my coordinate of M is going to be my x value of A plus my x value of B, and then I just divide it by 2, so I'm finding the average. And my y value of A plus my y value of B divided by 2. This is super important. Maybe I can just give another pointer on this, is sometimes you will have one coordinate and you have the midpoint, and then you need to find point B. Okay, this, you can look out for a question where, for example, you have a circle with a center, then they want you to reflect it about the line and find the equation of the other circle. Okay, so now you have the midpoint. Ooh, let me label this as M. You have the midpoint and you need to find the coordinates of B. So what I would do here is I write out my M, and I've already got my values here. Let's just give this thing a few values. So if this is -1 and 2, and then this is 2 and 3, what's B? So my midpoint is 2 and 3. So A, okay, so with my midpoint theorem, I'm going to say my x of A plus my x of B divided by 2 should equal to 2. That's the x coordinate. And my ya plus my yb divided by 2 should be equal to 3. Okay, I'm just going to make that there. This 3 is this 3 over here, and then you can plug in your value. So let's just plug in my x of A is -1 plus x of B. Okay, so if I take my 2 to the other side, that's going to become 4. I think I'm just going to quickly write that there. So my x of B is going to be 5. And here my y of A is 2. So my y of B is going to be equal to 4. So then I've got this point, which is 5 and 4. Okay, so that's really important to know for the midpoint theorem, that you can work either to find the midpoint, or if you have the midpoint, you can make two equations to find the point on the other side. This is a very typical type of question, so look out for that. Okay, then the third point that I have here is your distance formula. So if you've got A and B, then you can find the length of AB, and that really is just Pythagoras. So A and B. Okay, and what we want to do, it's pretty much the same as Pythagoras, so we just say our x of B minus our x of A, so that's going to give us that length over there, squared, plus my y of B minus my y of A, that's going to give me that length, squared is equal to AB. And then I just root it because it would be the same as equal to AB squared. Okay. So that's how you find the length. So those are three formulas that are not on your MF19. So you absolutely need to know those three formulas off by heart. And then I've just made a note here of a perpendicular bisector. So if you need to know the perpendicular bisector between A and B, what you want to do is you want to find the midpoint of A and B. That's over here. Midpoint of A and B by using your midpoint theorem. Then you're going to find the gradient of A and B by using your gradient formula. Change in y over change in x. And then you're going to find the perpendicular gradient. So m perpendicular times the m1 should be equal to -1. So then you can find the perpendicular gradient. And then you've got a formula for a straight line. So you can plug in your coordinate, which would be the midpoint. And you can plug in your m to solve for c. And then once you have that, you can just write your equation again, where you replace your values of m and c. Okay, so that's your perpendicular bisector, very important. Then I've already used it now. You've got a straight line equation. And then maybe I'm just going to write down another straight line equation here. Y1 minus y2 is equal to m. I don't know exactly the formula, but that's, I don't know if they say y2 minus y1 or y1 minus y2. It doesn't really matter. But that is another formula. And then another thing that you just need to look out for is sometimes they can just change the order of the function. So they'll have like 4x plus y is equal to 3. You just need to put it into a different format. So put it into this format to understand the different components. In this equation, my m is the gradient of the line, and then my c is my y-intercept. Okay, so I could just rearrange this to make y the subject of the formula, and then I should be able to find my gradient and my intercept. The same with this, I just multiply everything out, and then I've already got my gradient, but I'll have to multiply out and then collect like terms and make y the subject of the formula to find my c value. Okay, so that's just the equation of a straight line. Maybe I can just say it's important to know your gradient of a straight line. A gradient like this is equal to 1, so it goes across 1x and 1y. Okay, a gradient like this is something like m is equal to 2. So it goes across 1, but it's going to go up 2. Okay, so your change in y over your change in x. A gradient of a half, it goes across 2 and up 1. So it's helpful to know how the formulas work, just so that you can have an eye for these things. Obviously, if you're going negative gradients, this gradient is equal to -1.